Okay.
All right, boys and girls, let's talk about the ideal gas law. We talked about combined, all these other laws as well. So now we got this one. So let me just go ahead and write out the equation here for you.
Okay.
Pressure times volume is equal to nRT, temperature. I know what pressure, volume, and temperature are, but what are these N and R here?
So N is the number of moles. So you guys thought we were never going to talk about moles ever again. Not so much.
Not so much. And then R is
is the universal gas constant, and you will find this on your reference chart. And the value for this is 0.0821, and the units are liter times atmosphere divided by mole Kelvin. And this will make more sense once we start plugging it into the equation.
Okay, so that number never changes. It's constant. It doesn't change, but pressure, volume, and moles and temperature could possibly change. All right, let's run through what we have to have in units for these guys.
Okay.
So this actually right here, this units for the constant kind of tell us what the other things have to be.
Yeah, so if you ever forget, check your reference material and you know.
So my pressure always has to be in atmospheres, right? I see atmospheres there. Volume always has to be in liters. N has to be in moles. I don't think you could have it in anything else other than moles.
Nope.
And then temperature always has to be in Kelvin. So remember those units. If you're going to use that gas constant, you got to have those units right there. All right.
Okay.
So let's do a couple of examples. Let me just write this up here. PV equals nRT, so we remember. And I'm going to write down PV nRT because we're getting ready to do a problem, aren't we?
Yep. And something I always remember is the combined gas law, something's changing. So it's before and after. You have two situations. But with ideal gas law, you have one situation.
Just one thing you're taking a snapshot of.
You're just solving for one of the variables.
Okay.
And if you ever see moles, you're going to be using ideal gas law.
Okay, yeah. Good point. You see moles, ideal gas law. So what kind of problem do you have for me the first time?
So let's say we have 0.75 moles.
Okay, that's under N.
Of some gas.
Okay.
And we're at 15 liters.
Okay.
And 1.22 atmospheres at room temperature. 1.22.
Well, we got to solve for one of them. So let's say we have room temperature here.
Whoops.
That's okay. So room temperature 25 degrees Celsius, right? And then I know my gas constant R is always 0.0821. And then the units for that, liter, atmosphere, per mole Kelvin. All right.
So let's check units first.
So what are we going to have for pressure? All right. Our units, we have liters, moles, we have, Celsius.
So we got to convert to Kelvin.
I got to convert that to Kelvin. So how do I do that? I add 273 to 25, and that gives me 298 Kelvin.
Yep, so before you start plugging anything in, check your units.
All right, and I know my pressure now, since I'm using this gas constant, my pressure is going to be in atmospheres.
Right.
I know that. I'm going to go ahead and write that. Atmospheres, just to remind myself. So let's plug these numbers in, shall we? We've got pressure, which I don't know, times volume, 15.0, equals N moles times R times
298
T. Now, to get P by itself, you're going to have to divide both sides by 15. All right, so these cancel out. Pressure equals all that stuff on the top multiplied together divided by the bottom, and that's going to give me a pressure equal to
1.22.
1.22 atmospheres. If you're listening very carefully, she gave you the answer. Okay, so 1.22 atmospheres. That seems pretty easy. It's just plug and chug, as they say.
Yep.
So let's do another one. Let's do something a little bit harder. You have something harder for me?
So if we said how many grams of water do we have at a pressure of 1.3 atmospheres?
Okay, pressure is 1.3 atmospheres.
And 5 liters
5
for our
liters.
volume. And a temperature of 270 Kelvin.
Okay, I got the 270 Kelvin. I know my R is going to be 0.0821. And you said how many grams?
How many grams?
Wait, this is going to tell me
moles. And then we have to convert to grams using molar mass.
Molar mass is back again. Okay, well, let's solve for moles first, and then let's convert that to grams. And what did we say the substance was? Water?
Water.
So I'm going to write that right there so I remember which molar mass I'm going to use. So P is 1.3, V is 5.0, equals N, I don't know, R, which is my gas constant, times
270.
T. Okay, I'm going to have to divide both sides by this stuff here to get rid of it. Boy, this is making you guys a lot more comfortable with math, isn't it?
Nobody told you guys chemistry was all math.
Okay, so these cancel. N is equal to 1.3 times 5 divided by 0.0821 times 270. And we plug all that into the calculator and we get N equals
0.293 moles.
0.293 moles of water vapor. Okay. You said how many grams though?
Yeah, I did.
So let's do some more. So we got moles of water, train tracks. Let's extend that a little bit. I know 1 mole of water is 18.015 grams.
Yep.
Where my moles cancel out. Multiply those two together.
And we end up with 5.28 grams of water vapor.
5.28 grams of H2O vapor.
And we're done.
And that is it. Boy, that seems really easy. Kind of. If you couldn't follow and you had trouble with those conversions and everything, go back to the previous videos. There's no shame in that. And make sure you shore up those skills before you move forward.
Sounds good.